Hi guys, it's me Goknath here, and guys, today we're going to see integration by parts, which is one of the most important part of your indefinite integration. So guys, let me start to see about it. So by parts, what is this by parts rule and what does this by parts rule say? So guys, let me say there are two functions like your f of x. I'm saying there are two functions like your f of x and g of x such that they are in their product. So what I am saying is, I am saying that there are two functions like your f of x and g of x and they are in their product. That means f of x into g of x. I am having it like f of x into g of x. This is the product of these two functions. Now, if we need to integrate these two functions, what I will do? Is just I will put the integral symbol. Then I will write dx here in order to show that I am integrating with respect to x. I hope that makes you people clear. If I am having two functions like f of x and g of x which are in their product, and if I need to integrate them, then I will just put the integral symbol. Then I write dx here in order to show that I am integrating with respect to x. Now I need to integrate these two functions, and this is the place where I will be using your by parts rule. This is the situation where I will be using your by parts rule. So in case you need to you need to integrate two functions, and that is the place where you will be using your by parts rule. So listen carefully guys. Whenever you are having two functions and if you need to integrate them, and that is the place where you will be using a by parts rule. How will I be using your by parts rule? Is here I will be taking your f of x as your first function and g of x as your second function. When I take like that, this sort of integral form can be converted into other integral form. How it can be converted? Using a by parts. This integral form can be converted into other integral form by taking this f of x as your first function and this g of x as your second function. When you take like that, this type of integral form can be converted into other integral form using a by parts. How it can be converted? Listen carefully guys. First function which is f of x into the integral of your second function which is integral of your g of x of dx. So first function which is f of x into the integral of your second function which is integral of your g of x of dx, then minus of your derivative of your f of x which is nothing but the derivative of the first function which is nothing but your differentiation of your first function. So differentiation of first function will be nothing but your f dash of x, because the derivative of f of x can be represented as your f dash of x, and as we know your f of x is your first function, so derivative of first function will be f dash of x, then integral of your second function which is g of x. So integral of your g of x of dx. So derivative of your first function which is f dash of x into the integral of your second function which is integral of your g of x of dx, then I will integrate this whole expression. Just by putting the integral symbol here. When I put the integral symbol, I will put a dx on whole. And this is what our by parts rules say. So guys, I will repeat once again. So people who don't understand, again cope up with me. So we are having integral of f of x into g of x where your f of x is first function, g of x is second function. So this can be written as other integral form using a by parts. How it can be written is first function which is f of x into the integral of your second function which is integral of your g of x of dx, then minus of your derivative of your first function which is the derivative of f of x will be nothing but your f dash of x. F dash of x is the differentiation of your f of x into the integral of your second function, integral of your g of x of dx, then I will integrate this whole expression, not a particular expression, not a particular term. I will integrate this whole expression just by putting your integral symbol. Then I will write the dx after it on a whole. Because this dx is for this integral and this dx is for this integral. I hope you guys know that. So this is what our bypass rule say. So guys, please make a note of it because it is such an important rule. Because in integration, mostly in indefinite integration, we use this rule for solving the questions. Okay? And guys, now I know it will be looking little difficult, but anyway guys, you should memorize only because of such an important rule. So just practice more problems and you will be knowing what is this rule. And I know, now you guys will ask, which function do I choose as your first function or second function? And you will ask, is there any rule to choose your first function, second function, or we should choose it randomly? So guys, the type of function, that means you should not choose your first function, second function randomly. Okay, don't do that mistake. We should not choose your first function, second function randomly, but there's a rule to choose your first function, second function. Don't choose your first function, second function randomly as you think. For example, if I am having x sin x integral, then you will take sin x as the first function and x as your second function. If you take like that, then you will get full 0. So there is a rule for it. You should go with according to that rule. So you should not choose your first function, second function randomly. There is a rule for it. I will explain you the rule. So the first rule which you guys are need to follow while using a bypass is, that means to choose your first function, second function is, out of these two functions, check whether which function is easily integrable or you're directly integrable. Out of these two functions, check whether which function is easily integrable or it is directly integrable. And that function will be taken as your second function. Such a simple thing, na? Check whether out of these two functions, which is f of x and g of x, check whether which function is easily integrable or directly integrable and choose it as your second function. Why particularly second function? Because in your bypass rule, we are only integrating your second function, not at all the first function. Correct na? In the bypass rule, we are only integrating your second function, not at all the first function. See here na? See here. Correct, right? So in this bypass rule, we are only integrating the second function because in this first expression, I am integrating with g of x, which is the integral of second function. Even in this expression, I am only integrating your second function, integral of g of x. It shows that your second function only should be integral. I hope that makes you clear, and that's why I am saying you check whether which function is easily integrable or directly integrable and choose that function as your second function, and that is one of the important rule which you guys need to understand. So which function is easily integrable will be taken as a second function because in this bypass rule we are only integrating your second function, not at all the first function. Now, as you guys are more thinkative, you will ask me, if both the functions are easily integrable or it is directly integrable, then what would I do, man? You guys will ask. There is also a rule for it. If both the functions are easily integrable and they are directly integrable means, then what would I do, you will ask. What would I do is, you will use a rule known as Eyelet Rule. Guys, a very important rule. Eyelet Rule. What is this Eyelet Rule? If both the functions are integrable, easily integrable, then you will use your Eyelet Rule. What is this Eyelet Rule is, I will say the full form of this Eyelet Rule because it's the abbreviated form. Not any particular terminology and all. Not any particular terminology, or there is no definition for this. There is only a full form for it. That means the abbreviated form. So your I will be nothing but inverse function. Rather than I will say itself, guys, I don't need to write it all because no space it, right? So I will write here. Your I will be nothing but your inverse function, and L will be nothing but your, okay, your I will be nothing but your inverse trigonometric functions. L will be nothing but your logarithmic functions. Logarithmic functions. So L will be nothing but your log. One minute guys, so I'll take the duster. So I will write it as log itself, okay? So L will be nothing but your logarithmic function, and I will be nothing but your inverse trigonometric functions, and A will be nothing but your algebraic functions, which is ALG. Then I will write it as functions here. And your T is nothing but your trigonometric functions. Trigonometric functions. I think I wrote wrong. Trigonometric. Guys, I am just writing in a small form, okay? You guys know what is the spelling, right? Then trigonometric function, and E is nothing but your exponential function. So every letter corresponds to a type of function, exponential. Exponential function. So guys, I will tell once again, this Eyelet rule is a abbreviated form, not a definition. Your I is nothing but your inverse trigonometric function, L is nothing but your logarithmic function, A is nothing but your algebraic function, T is nothing but your trigonometric function, E is nothing but your exponential function. Your spelling is wrong, don't blame me, okay? Guys, I know spelling is correct only, okay? Spelling is correct, exponential correct, algebraic correct. That is why I did not write the full spelling, okay? So that's all. So Eyelet abbreviation I wrote here. Now you guys will ask, what man, you are telling Eyelet, you let, I'm let, but you are not telling what is the use of it. I will tell now. So guys, try to understand. What is the use of Eyelet rule is, let me say one example. Like your integral of x sin x. Now, tell me one thing, which function you will be choosing as your first and second function? Now, tell me what is your x? Your x is nothing but your algebraic function. Correct now? Your x will be nothing but your algebraic function. Sin x will be nothing but your trigonometric function as per your Eyelet rule. Okay? So, in this integral of x into sin x, here you will be using a bypass rule because there are two functions and this x is nothing but an algebraic function and sin x will be nothing but a trigonometric function, algebraic and trigonometric function. Now, here we know that your algebraic function is before your trigonometric function in your Eyelet rule. Correct now? This algebraic function is before your trigonometric function in your Eyelet rule. That means I will be taking this algebraic function which is x as your first function. And I will be taking this trigonometric function sin x as your second function. Why? Because your trigonometric is after your algebraic. If your trigonometric is after your algebraic, I will be taking your sin x as your second function. So I will repeat once again, x is your algebraic, sin x is trigonometric. So x will be taken as your first function because algebraic is before your trigonometric, because A is algebraic, T is trigonometric. A is before your T and that is why we will be taking x as your x as your first function and sin x will be taking a second function because the T is after your A. So what you can conclude is the term which is at the leftmost part of the Eyelet rule for you people will be the first function, and the term which is in the rightmost part in the Eyelet rule for you people will be taken as a second function. I hope that makes you people clear. So the term which is in the leftmost part for you people will be taken as your first function, and the term which is at the rightmost part for you people will be taken as your second function in the Eyelet rule. Okay? I hope that makes you clear. As algebraic is before trigonometric, that is why you are taking x as your first, and trigonometric is after your algebraic, and that's why you are taking it as a second function. So that's all guys. Please don't forget this Eyelet rule, because this Eyelet rule is something which is very, very important. Using this only I am saying x will be your first function, sin x will be trigonometric function. As your A is before T, that is why your x will be algebraic function, which is nothing but the first function. If x is algebraic, sin x trigonometric, then x will be the first function, sin x will be second function. So that's all guys. That's all about this concept, and let us solve one question based on this bypass rule so that you will be very good at the bypass rule. Because guys, mathematics without problems means what is the beauty in it? So let me solve one question based on this bypass rule so that you will be much clear in the concept. So let me solve one question based on the by parts rule. Our question is integral of x into secant square x of dx, and this is a direct by parts application question, by parts rule application question. So guys, which function will you be choosing as your first function and second function is? We know that your x is your first function, secant square x will be second function. How? That's by your Eyelet rule. Few minutes before only I taught you the Eyelet rule. In Eyelet rule, we know that your x is algebraic function and secant square x is nothing but your trigonometric function. An algebraic function is in the leftmost of your trigonometric function in your Eyelet rule, and that is why I am taking this x as your first function and this secant square x as your second function. So secant square x will be nothing but your second function. Why? Because your trigonometric function is after your algebraic function. Because secant square x is your trigonometric function and trigonometric function is after your algebraic function in your Eyelet rule, and that is why x is your first function and secant square x will be nothing but your second function. I hope that makes you people clear. Okay. Now I will write the by parts rule below. Okay. What a by parts rule says integral of f of x into g of x. F of x into g of x of dx can be written as f of x into integral of g of x of dx, then minus of the derivative of your first function, which is derivative of f of x, will be nothing but a f dash of x. These things you should know because 12th standard guys, these and all you should know. So derivative of f of x is nothing but a f dash of x. It can be represented as f dash of x. Then into integral of your second function, which is integral of g of x, then dx, then I will integrate this whole expression by putting a dx here, and this is what our by part rule say. So integral of f of x into g of x of dx can be written as f of x into integral of your g of x of dx, then minus of your derivative of a first function, which is the differentiation of your f of x, will be nothing but a f dash of x into the integral of your second function, which is the integral of your g of x of dx. Then I will integrate this whole expression by putting an integral symbol. Then I will write dx on whole, because this dx is for this integral and this dx is for this small integral. I hope that makes you people I hope that makes you sense. So this is what our by part rule say, and I told it in the concept itself. So I will apply this rule in this question. Now as we know, your x is your first function and secant square x is your second function. So using a by parts rule, how would I convert this integral is, listen carefully guys, this can be converted as f of x, which is your first function, which will be nothing but x, into integral of your second function, which is integral of your secant square x, then of dx, then minus of the derivative of your first function, which is derivative of x. What is the derivative of x? That is your x1. Because guys, we are having f dash of x. F dash of x is nothing but the derivative of f of x. So derivative of first function will be nothing but 1 only, because derivative of x is 1. The differentiation of x is 1 into integral of your second function, which is integral of your secant square x. I will write here integral of secant square x. Then of dx. Then I will integrate this whole expression by putting a dx on whole. This is what you will be getting as a simplified value when you use this form of expression, which is nothing but the by parts rule. So by parts rule, I am just using this by parts rule which I wrote below in this integral and just converted into first function, which is f of x, that will be nothing but x, into integral of a second function, which will be nothing but integral of secant square x of dx, then minus of the derivative of your first function, which is derivative of x, will be nothing but 1, into integral of your second function, which is integral of secant square x of dx. Then I will integrate this whole expression by putting a dx on whole. Now just simplify the value guys. So x into, what is your integral of secant square x of dx? Integral of secant square of dx is nothing but your tan x. Because guys, this is the basic formula that you guys learned in your integration, indefinite integration. So integral of secant square x of dx will be nothing but tan x. Integral of secant square x of dx will be nothing but your tan x. Then minus of integral of this big integral. Integral of 1 into integral of secant square x of dx. What is integral of secant square x of dx? That is nothing but your tan x. So 1 into tan x will be nothing but your tan x of dx. Now, so what I did is x is x only, then integral of secant square x of dx is nothing but your tan x. That's your integration formula. Then this big integral I wrote, then 1 into integral of secant square x of dx. Again integral of secant square of dx is nothing but tan x, your basic formula of your indefinite integration. So integral of secant square x of dx can be written as tan x. As we know, integral of secant square x of dx is nothing but your tan x, which you guys learned in your indefinite integration. So this integral of secant square x of dx is nothing but tan x. So 1 into tan x will be nothing but tan x of dx. So integral of tan x of dx we are having in the second expression. Now guys, it's very simple. X is tan x only. Then minus of integral of tan x dx. What is integral of tan x dx? That is nothing but your ln of secant x or ln of cos minus of ln of cos x. Integral of tan x is nothing but ln of secant x or minus of ln of cos x. You guys know that, right? We know that integral of tan x can be written as, I will write here itself. So integral of tan x is nothing but tan x of dx is nothing but ln of secant x of plus some constant or ln of minus of ln of cos x plus some constant, because right, these are two ways which you can write this integral of tan x of dx. So integral of tan x of dx can be written as ln of secant x plus some constant or minus of ln of cos x plus some constant. Now I will take this integral of tan x of dx as minus of ln of cos x. When I take like that, minus will be converted into plus. So plus ln of cos x, then plus some constant, and that's all guys. Just simplify it. I will repeat once again. X tan x I wrote here. Then minus of integral of tan x dx. What is integral of tan x dx? As we know, you can write this integral of tan x dx in two ways, which is ln of secant x or minus of ln of cos x plus some constant. See, which is integral of tan x dx can be written as ln of secant x plus some constant or minus of ln of cos x plus some constant. So here I am taking this integral into the account, this form of expression into my account. When I take this form of expression into my account, when I write this integral of tan x dx as minus of ln cos x plus c, I will get minus of minus ln cos x plus c, minus of minus ln will be nothing but plus ln cos x plus some constant, and this constant is nothing but the sum of all the constant of the every integral. Okay, so guys, don't do this mistake. If there is multiple integrals in your question, you can write one constant itself, because this itself I came to know before 4 months only. Before few months only I was able to know that by your one JEE mains question. While solving a JEE mains question, there is a multiple integrals in the question. In the options, there is only one constant, and that is a place where, and that is when I was able to know that even though we have multiple integrals in the question, we should put only one constant, and that one constant is nothing but the sum of all the constant of your multiple integrals. I hope that makes you people clear. So you should only write one constant even though we have multiple integrals here. If you have multiple integrals, you can write one constant itself, because this constant is nothing but the sum of all the constants of those multiple integrals, and that's all. Okay, so this I converted using a formula by using minus of ln of cos plus some constant c. So that's all guys, and this is your answer, and that's all about this session, and that's all guys. I hope you guys would have understood the concept, and I hope you guys would have enjoyed the solving part. That's all guys. Thank you. Make education simple.